I'm Sujata from CBSE NEET JEE Chemistry.in. Welcome to JEE Last Mile Preparation Series. Now we have divided the questions or contents into three parts: organic, physical, and inorganic. You will find questions from all topics that you have learned in classes 11 and 12. We begin with organic chemistry. The first chapter in organic chemistry that you have learned in class 11 is purification and characterization of organic compounds. It deals with the qualitative and quantitative estimation of elements. Now, two numerical oriented questions have been chosen. All right. Now, question one involves choosing the correct answer from four given options. This type of a question will appear in section A of your exam paper. Now, let's start discussing the question. But before you start solving the question, pause the video, read the question, solve it on your own, resume watching the video, and analyze whether there is any difference in the approach to solving the question. Okay, so let's start with question number one. 0.246 gram of an organic compound on complete combustion produced 0.198 gram of carbon dioxide and 0.1014 gram of water. You need to find out the ratio of carbon and hydrogen atoms. Okay, you know that carbon dioxide and water are the products of complete combustion of an organic compound. All the carbon present in the organic compound is converted to carbon dioxide, and all the hydrogen present in the organic compound is converted to water. You are given the masses of carbon dioxide and water, right? You have not been told in the question that carbon and hydrogen are the only elements in the compound, so be alert about it. All right, so carbon and hydrogen ratio is what you need to determine. There could be other elements present. All right, so let's get started with the question. Solving the question. Now, there are two approaches to solving the question. The first approach would be the percentage method. Okay, so first you find out the percentage of carbon from the given mass of carbon dioxide and the percentage of hydrogen from the given mass of water. You must be aware of the shortcut formula to find out the percentage of carbon. In 44 grams, the molar mass of carbon dioxide, there are 12 grams of carbon. So, in 0.198 grams of carbon dioxide, this is the mass of carbon, 12 by 44 into 0.198. Now, this mass of carbon is present in 0.246 gram of the organic compound into 100. This would give you the percentage of carbon. Let's try to simplify the problem. We can just round off certain numbers because we have to solve this question very quickly. So 12 by 44 into, we can round off 0.198 to 0.2, and denominator, we can round it off to 0.25 into 100. All right. Now, 12 by 44, now 0.2 into 100 will be 20 into 0.25, I am removing the decimal, I am introducing 100 in the numerator. So 0.2 into 100 is 20 and 0.25 is nothing but 25 by 100. Now we know that 25 fours are 100, 4 11s are 44, right? Now we can easily solve the rest of it. 240 by 11. So 240 by 11 would be 11 twos are 22. You have 20 here, 11 ones are 11, and then you have 21 point, say 9, so 11 eights are 21.8% will be the percentage of carbon. Slight approximation. Okay, let's also find out the percentage of hydrogen. Had carbon and hydrogen been the only elements, you could have found out the percentage of hydrogen as 100 minus percentage of carbon. But here you don't know whether there are other elements or not. So let's find out the percentage of hydrogen from water. In 18 grams of water, which is the molar mass of water, there are 2 grams of hydrogen, H2O, right? So in 1014 gram of water, what is the mass of hydrogen? This is the mass of hydrogen. This mass of hydrogen is present in 0.246 gram of the organic compound, and into 100 will give you the percentage. Let's do some rounding off of numbers to make the calculation easier. 2 by 18. Let's retain this as 0.1 and let's convert 0.246 to 0.25 into 100. So similar calculation, 0.1 into 100 is 10 into 0.25 would be 25 by 100. So we again cancel 25 fours are, right? So here we have 20 into 4, 80 by 18. Well, 2 nines are 18 and we can make this 240. 40 by 9. 40 by 9 would be 4 point something. 9 fours are 36. Again 4.44, etc. It could be rounded off to 4.5% because we have made an approximation in these two digits. All right. So it could be approximately 4.5%. So now we have the percentages of carbon and hydrogen. How do we proceed beyond this? Next, what we do is we've got carbon, hydrogen, percentage. Percentage of carbon is 21.8. Percentage of hydrogen was 4.5% approximately, 4.5. Let's now convert percentage to relative number of atoms, which is percentage by the atomic mass. So 21.8 by 12. 21.8 by 12 and this is 4.5 by 1. Now this would be 1.98. So you have 12, 8, SAR 96, approximately 1.8, 96 and then you have 20, so approximately 1.8 and this is 4.5. Now you convert this to the simplest whole number ratio. So divide this by the least. So whatever you've got here, percentage by relative atomic mass, divide by the least number. So 1.8 is the least number. So 4.5 by 1.8, which is 45 by 18. So you can have 3 6 are 18 and you can 345, so 15 threes are 45. So this comes to approximately 2.12, 30, 2.5, right? So now you have the ratio 1 is to 2.5. The whole number ratio would be obtained by multiplying by 2. So you get 2 is to 5, right? So this will be the ratio of the number of carbon and hydrogen atoms. 2 is to 5. Okay, let's do an alternate method and you can decide whichever method is easier. You can adopt that method to solve this problem. The second method is the moles method. Okay. Now, first we find out the number of moles of carbon from carbon dioxide. So you've got carbon dioxide here and carbon. We know that 1 mole of carbon dioxide contains 1 mole of carbon. So ratio is 1 is to 1. What is the number of moles of carbon dioxide? Given mass divided by molar mass. Given mass is 0.198 divided by molar mass, right? So this will also be the same 0.198 by 44, which can be rounded off to 0.2 by 44. All right. Now 0.2 by 44 would be 2 by, okay, approximately 2 into 10 to the power of minus 1 by 44, or we can simplify it further by writing 200 into 10 to the power of minus 3 by 44. Okay, so how do we get this answer? How do we continue with this? This will be approximately 4.5 into 10 to the power of minus 3. So in this manner, you find out the number of moles of carbon atoms. Next, let's find out the number of moles of hydrogen atoms from water. So here again, water and hydrogen. 1 mole of water contains 2 moles of hydrogen. So let's first, so here the ratio is 1 is to 2. So let's first find out the number of moles of water. So given mass by molar mass, given mass is 0.1014 divided by 18. So this would be 2 into 0.1014 divided by 18. Let's simplify it further. 2 into 0.1 by 18. zero point 0.2 by 18, which is, you can have it say, 2 into 10 to the power of minus 1 by 18, or 20 by 18 into 10 to the power of minus 2. So this would be 1.1 into 10 to the power of minus 2. Approximately 1.1 into 10 to the power of minus 2, or 1.12 into 10 to the power of minus 2. That would be the number of moles of hydrogen atoms. Okay, so now what do? We have straight away got the number of moles of hydrogen atoms and carbon atoms. Number of moles of carbon atom is 0.0045, and the number of moles of hydrogen atom is, we've got the value here, which is 1.12 into 10 to the power of minus 2, which is 0.0122, right? 112. Now to find out the simplest whole number ratio, we divide by the least number of moles. So 1, and this would be 0.0112 divided by 0.0045. All right, now this will be approximately, so this will be approximately 1 is to 2.5. So 45 twos are, yes, 45 twos are 90.5. And here again, you multiply by 2, multiply by 2, you get the ratio 2 is to 5. So finally, what is the correct answer? The correct answer would be option C. Okay, so you could choose whichever is an easier option, whichever is an easier method of calculation, you can adopt that. So this is how you get the answer to question number 1. So here is question 2. So question 1 dealt with the estimation of carbon and hydrogen in an organic compound. Question 2 deals with the estimation of nitrogen. And nitrogen can be estimated by the Duma method and the Geldal method. Geldal method calculation can be a little more challenging than the Duma method calculation, and hence the Geldal method question has been chosen here. Now this question, which is a numerical value type question, will appear in section B of your exam paper. So let's get started. All right, let's first familiarize ourselves with the question. 29.5 milligram of a nitrogen containing organic compound was analyzed by Geldal's method, right? And the evolved ammonia gas was absorbed in 20 milliliters of 0.1 molar hydrochloric acid solution. The excess acid required 15 milliliters of 0.1 molar sodium hydroxide solution for complete neutralization. The percentage of nitrogen in the compound is. So you have to arrive at a number, an integer, with 2 digits after the decimal. All right? The instruction would be given in the question paper, and you must be already aware of it. All right? Okay. So now let's get started with the details of this question. I just want you to be very sure about the fact that you have already learned this chapter, this particular Geldal's method in CBSE class 11 topic, as a class 11 topic. There you've come across the analysis by Geldal's method where they use sulfuric acid and not hydrochloric acid. A shortcut formula has been arrived at for finding out the percentage of nitrogen in the organic compound. Now, the formula that you have seen in your CBSE textbook in class 11 under this chapter corresponds to the use of sulfuric acid, okay, instead of hydrochloric acid. So their sulfuric acid is neutralized by sodium hydroxide. The unreacted sulfuric acid is neutralized by sodium hydroxide, and the mole ratio between sodium hydroxide and hydrochloric acid is different. Sorry, with sulfuric acid is different from the mole ratio between sodium hydroxide and hydrochloric acid. Sulfuric acid is a diprotic acid. So the ratio between sodium hydroxide and sulfuric acid is 2:1. Whereas the ratio, hydrochloric acid being a monoprotic acid, the ratio is 1:1. All right. So what I'm going to do here is write the details of this calculation and arrive at the shortcut formula corresponding to hydrochloric acid. So you have to be very alert while using any shortcut formula, especially in Geldar's method. So I'm repeating, whatever you have learnt in class 11 corresponds to sulfuric acid. And that is why you see 2 into V2 minus V1. Whereas here, hydrochloric acid is a monoprotic acid. We don't need that 2 in the formula. We will arrive at the shortcut formula after dealing with this question in a proper conceptual manner so that your understanding is absolutely clear and you will not make use of an incorrect shortcut formula. All right? Okay, so let's get started. So here, let's start with this. Let's understand the question. Now, this compound is a nitrogen-containing compound. I'm not getting into details of Geldar's method, but what we have to understand is whatever nitrogen is present in the organic compound has been converted to ammonia gas. All right? And this ammonia gas is is exposed to hydrochloric acid. You are provided with 20 milliliters of 0.1 molar hydrochloric acid solution. All right. But we know that all of the 20 milliliters is not used to absorb or to react with ammonia gas evolved. There is some unreacted or unused hydrochloric acid. The unused or the unreacted hydrochloric acid is estimated. The amount of unused or unreacted hydrochloric acid has to be estimated. How? That is done by neutralizing the unreacted or unused or excess hydrochloric acid with sodium hydroxide solution. You're provided with the volume and concentration of sodium hydroxide solution. So from this, we get information regarding what is the unused hydrochloric acid. We have the initial hydrochloric acid here. The difference will give us the amount of hydrochloric acid that reacts with ammonia gas. And then we progress with the calculation from that point. Okay, so let's deal with the initial steps. Okay, so now let's go to here. So what we have understood is, so we have sodium hydroxide. So first let's find out. So let me write step 1 here. We are finding out the amount of unreacted or excess hydrochloric acid. That is our first step in the calculation. Now, sodium hydroxide and hydrochloric acid bear a 1:1 mole ratio. So that makes it very easy. We are provided with 15 milliliters of 0.1 molar sodium hydroxide. Now, this will neutralize 15 milliliters of 0.1 molar hydrochloric acid because the mole ratio is 1:1. So here we have the volume and concentration of hydrochloric acid, which is unused. So this is the unused or unreacted hydrochloric acid. All right. So we have got this information. Now let's find out what is the amount of hydrochloric acid which has reacted. So that is step 2. Okay, which is amount of reacted hydrochloric acid. Okay, amount of reacted hydrochloric acid. So that would be, so let me write this. Initial amount of hydrochloric acid was 20 milliliters of 0.1 molar hydrochloric acid. We know the amount of unreacted hydrochloric acid. Therefore, the amount of reacted hydrochloric acid would be 20 minus 15 milliliters of 0.20 minus 15 milliliters of 0.1 molar hydrochloric acid, which is 5 milliliters of 0.1 molar hydrochloric acid. So we now have the amount of reacted hydrochloric acid. Now let's connect it to the ammonia gas which is evolved. The ammonia gas produced by the nitrogen containing organic compound reacts with 5 milliliters of 0.1 molar hydrochloric acid. Okay, so for that, let's first see. So that is step 2 is over. Now we move on to step 3. In step 3, we are going to find out, okay, the amount of ammonia. All right, the amount of ammonia evolved by the organic compound. Okay, so now let's start. Let's first find out the mole ratio between ammonia and hydrochloric acid. Ammonia and hydrochloric acid react to give you ammonium chloride. So what is the mole ratio? 1:1. All right. So here again, if it is sulfuric acid, it would be 2:1. So here it is 1:1 hydrochloric acid. Okay. So now let's get started. Because of this ratio, 5 milliliters of 0.1 molar hydrochloric acid will absorb the same amount, 5 milliliters of 0.1 molar ammonia solution. So this is the result of this particular information. So we now know that 5 milliliters of 0.1 molar ammonia, this is the amount of ammonia gas evolved by the organic compound. Okay, now let's connect ammonia to nitrogen. Its molarity here. Molarity corresponds to the number of moles in 1000 milliliters. So let's now make the connection. So 1 molar solution would correspond to 1000 milliliters. Here we have 5 milliliters of 0.1 molar ammonia. Okay, so now let's go to step 4. So here we have step 4. In this step, we are going to find out the mass of nitrogen in the organic compound. Mass of nitrogen in the organic compound. All right. So how do we do that? So let's get started. So now we know that 1000 milliliters of 1 molar ammonia. Okay. So 1000 milliliters of 1 molar ammonia would contain 1 mole of ammonia, correct? Molarity is equal to number of moles divided by volume, and 1 molar implies 1 mole of ammonia is dissolved in 1000 milliliters of the solution. So 1000 milliliters of 1 molar ammonia solution contains 1 mole of ammonia. Now, 1 mole of ammonia corresponds to 17 grams of ammonia. So, if 17 grams of ammonia is 1 mole related to the mass of nitrogen, so 1 mole of ammonia or 17 grams of ammonia would contain, therefore, 14 grams of nitrogen. Okay, so we have connected ammonia to nitrogen. Let's keep 1 molar and now find out what is the mass when the volume is 5 milliliters. That is the amount of ammonia that we got. Okay, therefore, 5 milliliters of 1 molar ammonia corresponds to what mass? That would be 14 into 5 into 1 divided by 1000 into 1 molar divided by 1000. Okay, so many grams of nitrogen. All right, now we want in 0.1 molar. Therefore, in 0.1 molar ammonia, what is the mass of nitrogen? So this into 0.1. So 14 into 5 into 0.1 molar divided by 1000 grams of nitrogen. So this would be the mass of nitrogen in the organic compound. All right, so we got the mass of nitrogen. Now, what is the final step? We have to find out the percentage of nitrogen in the organic compound, right? So now let's do that step. The next step, so this was step 4, and now we move on to step 5, the last step, to find out the percentage of nitrogen in the organic compound. Now the unit is gram, so let's convert the mass of. So here the mass of the organic compound is in milligram, 29.5 milligram. So what is the mass of the organic compound in grams? Mass of organic compound in grams would be 29.5, right? 29.5 into 10 to the power of minus 3 grams, right? Or 29.5 divided by 1000 would be the mass of the organic compound. Okay, so now let's see, let's find out the percentage. So percentage of nitrogen would be the mass of nitrogen. What is the mass of nitrogen? 14 into 5 into 0.1 divided by 1000. Okay, into 100 percentage divided by the mass of the organic compound, 29.5 into 10 to the power of minus 3. Okay, this is the conceptual, this is how we deduce the formula conceptually. This understanding is very important. All right, now let me lead you to the shortcut formula if hydrochloric acid is used. Okay, so what is it? So what is the shortcut formula? So I'm retaining 14 into what? How did you get 5? V2 minus V1, 20 minus 15. Let me write the values first and then I will write the formula. Into 0.1 molar into 100 divided by 1000 into 29.5 into 10 to the power of minus 3. Okay, so now the final calculation, the final shortcut formula that you have seen is 100 divided by 1000 is 0.1. Okay, or 1 by 10. 14 by 10 would be 1.4 into V2 minus V1, 20 minus 15 into 0.1 molar divided by the mass of the organic compound. So what is the shortcut formula that you arrive at? I'm going to highlight this formula. The shortcut formula would be, if hydrochloric acid and 0.1 molar solution is used, the shortcut formula would be 1.4 into V2 minus V1 into molarity divided by W. W would be representing the mass of the organic compound, right? So this would be the shortcut formula for percentage of nitrogen if hydrochloric acid is used. Okay, I've told you in the beginning why there is a difference if you use sulfuric acid and if you use hydrochloric acid. So all those points have to be kept in mind. You should not straight away use the formula that you've learned with sulfuric acid and arrive at the final answer. Okay, so this formula is very important. So we have arrived at the shortcut formula. So if you now get a question with hydrochloric acid, you know you don't have to go through all this. If you've understood the concepts very well, straight away use this formula and arrive at your final answer. Okay, now let's continue and complete that final answer here. So we are going to use this formula wherein we have, yes, so I'm not using this formula. It's easier to calculate using this formula. Okay, or you can use this formula and substitute. You can do this. 1.4 into 5 would be 7. 7 into 0.1. So I'm retaining 0.1 as 10 to the power of minus 1. So 10 to the power of minus 1 into 10 to the power of 3 would be 10 to the power of 2 divided by 29.5. All right, I'm trying to make the calculation easy. Okay, so this would be 700 by 29.5. To remove this decimal, 7,000 divided by 295. Okay, 7,000 divided by 295. And if you cancel this, solve for this, you will get the percentage as 23.7%. Okay, 0.71 or 72%. So this is the final answer to this question. Okay, so make sure that you understand what kind of formula to use. Even though you've learned so many shortcut formulae to help with time management, you should be very alert and not use the wrong formula. All right. I'm sure you have found these questions very useful. I will see you tomorrow with 2 questions from the next chapter, some basic principles in organic chemistry. Thank you.